Whoa.
We're too quiet, everybody. We can create a ruckus today.
So this should feel a lot like, where we came from. Oh, reminder. Yes, thank you. I saw your hand. Data types. So Shay asked, how would you drill into this hash if you wanted to get the favorite color of this person? All right, so we said person, and then we could ask for their phone number. Let's go back to this one. So, right. I do, thank you. What is it with being commas today? It's weird, right? Oh, and this is a symbol now, so it's phone number. Notice that I can't now use strings, right? I'm using symbols, so this was a nil. So this is how you would get the phone number. If I asked for the details, this would give me back a hash, right? So person details is a hash. For just a second, I'm going to put parentheses around this, because that parentheses represents this hash. And then I could ask that hash, hey, give me the favorite color. Right? Blue. Another way you could think of this is we could say details equals the person's details, and then print the details favorite color, right? Because this gives us back a hash. This should give me back blue. But we could just combine these, right? Since we apply the rule, like if we're only using the variable one time, rule, oops. This is person details. So you can chain the brackets along like that to access them. This is a lot like in JavaScript where you would say person.details.favorite color. Our hashes by default don't have the dot notation. We have the bracket style notation, and you can chain them along. Right. So this is how we would do this in JavaScript. Person.details.favorite color. Here we do them in brackets with the keys. Person details, favorite color. Pretty much the same thing. We just don't have a dot notation. Cool. So there's a pretty good write-up here about classes. The classes in Ruby are going to look a lot like our classes in JavaScript. Let's make a dog class. Boy, this sure looks like the syntax from JavaScript, right? Let's make it so that when we create a dog, we give it a constructor. In JavaScript, right, we had a constructor, and this is what we were creating every time we would make a new one, the constructor would be called. In Ruby, we call this the initialize. And I always spell it wrong, because I think initialize is a weird word to spell. So I get this wrong a lot. But this is the method that gets called whenever we make a new instance of dog. Dog, right? Initialize. And the way we make a new dog is my dog's called Riley. And the syntax is a little bit different, right? In JavaScript, we would say const Riley is new dog, right? Here, the new method is tacked onto the end of dog, dog.new. Please dog class, make a new one of you called Riley. Let's print what Riley is. So you see that the programmer's print for this just tells us what kind of thing it is, and is very unuseful. Where does it live in memory? Right? It's a little bit helpful because if we had another dog, so this is Jenna's parents' dog, Roscoe, we would see that those are both dogs, but they're different dogs. This is the dog who lives here in memory. This is the dog who lives here in memory. Right? Two instances of a dog, but different dog objects. Right? Much like JavaScript. The idea is exactly the same. So let's give these dogs something to remember. So in JavaScript, we would do something like this.name is Riley. Right? And that's how we told this instance of this dog's name is Riley. In Ruby, we use an idea called instance variables. So instance variables are the second kind of variable we're going to learn. And they're just like regular variables, except we call for them a little bit differently. We put an @ sign in front. We say @name is Riley. If I just did name equals Riley, the name variable is a local variable. It only exists while this method is running, and at the end, Ruby lets it go. So if we want our class to remember something that's specific to this instance of a dog, we use instance variables. This variable goes away when the method is over, but @name sticks around. Right? The variable, the instance variable, sticks around as long as this dog instance is being used by our program. But the local variable poofs at the end of the function, at the end of the block. So now let's run this. Aha! Now the programmer print for our class tells us a little bit more. This is the instance of dog that lives at this funny memory address, but its name, its instance variable, name is Riley. But this one's name is also Riley. Right? They both have their own copy of Riley as the name. Right? This instance thinks its name is Riley, and this instance thinks its name is Riley. So if we want to customize this, right? If we want to customize this, we have to give our initializer some information. Let's call the argument the dog name. Okay, so now if initialize takes an argument, we're going to get an error when we try to make a new dog. Right? It's saying that on line, where are we? Classes RB on line 5. Hey, we're trying to pass something that's expecting one argument, but we gave it 0. And that's happening from line 23. So this is where the error happened. This is the thing that started it. This is a case where the .NET students would be doing the same thing. Their program wouldn't even run. So this is a runtime error, right? When I was making my code, nothing was warning me like, hey, silly, you've told me now that dogs, when they're created, need to provide a name. You have now made a mistake down here. I don't find out until I run my program and I get this error. So now what it's saying is I need to provide a single argument to my class. I need to provide the dog name as input or an argument to this initializer along the way, right? Except I need to use that to store that value in my instance variable. I'm passing in Riley when I make my new dog as the dog name, and then I tell the dog class, this is important information. The dog name that you just got in is important. Please store that as my dog's @name. And now if I run this code, I have 2 instances of dog, one whose name instance is Riley, the others whose instance name is Roscoe. So same class, different data. Right? Normally, we would probably call this variable name and this name, but I think that gets sometimes a little confusing, right? So I made the argument name a little more explicit, but most programmers are just going to call that argument name. It's a Taco Tuesday.
It'd probably make a little more sense if down below Riley said Pitbull and Roscoe said Dotson.
Maybe. This is more like we're going to call the dog, like, come here, right? So let's do this. Let's add a second thing, which is the breed. This is interesting, right? So let's add a second argument, which is the breed. They both happen to be dachshunds. And I always misspell dachshund. Is that right?
Yeah, I think that's right.
Good enough.
No, without the H, the second H.
Like this?
I think that's right.
Let's go with it. Spelling be damned. Somebody can look it up while I'm talking. So now this takes two arguments. Let's make two instance variables. So I'm going to make a second instance variable called @breed. That's going to store the breed. Now when I run this, my little programmer print says, hey, each of these objects has two instance variables. I can have as many instance variables as I like, and I can call them whatever I like. Right? Whatever my class needs to remember, that's what my instance variables are going to do. Let's give this dog class some behavior. Let's define a method. Notice now that this method is inside of the class. Right? This is now an instance method of the class, meaning I need there to already be a dog created before I can ask this to speak. Right? The same rules about methods now apply. Right? I can have this puts the dog named @name that is a breed says woof. Right? So inside of these methods, if I want to refer to this particular dog's name, I say @name. And if I want to refer to this particular dog's breed, I say @breed. And now I can ask, hey Riley, I would like you to speak. And hey Roscoe, I would like you to speak. The dog named Riley that is a dachshund says woof, and the dog named Roscoe that is a dachshund says woof. Right? These are instance variables inside of an instance method. I need there to be a specific Riley and for there to be a specific Roscoe, right? In order for them to speak, they have their own instance variables, right? This is Riley's instance variable. So you see when I ask this dog for @name, I get back Riley. If I ask this dog for @name, I get back Roscoe. Wouldn't it be nice if I could print Riley's name? Nope. So unlike JavaScript classes, I cannot ask for instance variables from inside of a class. The instance variables are private. They're details of that class. I can't from the outside ask for them by default. If this were a JavaScript object, I would be able to see all of those attributes. This dot name, I could ask for dot name on that object. In Ruby, we can't by default. But nothing stops me from defining a name method that just returns the instance variable. Right? So why don't I just make a method called name, and it just returns @name. Riley. But wasn't one of the rules I can drop this return? Right? So the method name just returns @name. Awesome. Now I can get the name of Riley, and I can get the name of Roscoe. We do this so often, we want to expose these instance variables that Ruby gives us a shortcut, right? Because I would also have to do this, wouldn't I? And imagine if I had 12 other things that I wanted to share, right? But maybe one I don't, right? So rather than have to say def name, def breed, def age, def, right, favorite toy, whatever it is, that gets pretty boring. And Rubyists hate repetitive things. So rather than that, we have a special thing we can add at the top called an attr reader. So attr reader stands for attribute reader. It says the following attributes, the following instance variables, I want other people to be allowed to read. And I let them know by giving it a list of symbols. Please let the name and the breed be accessible as readers. Right? Attr reader says, take this symbol and say the same instance variable name, please make that a method that I can call on. Take this symbol and make a method called breed that gives me the @breed instance method. So it's a shortcut. It's a shortcut for def name @name and def breed @breed. Right? It's a shortcut for this. So I can just make a whole long list of all the instance variables that I want to have, and now these things still work. Yay! Right? Ruby's always trying to make me write less code.
I'm sorry, backing up, why couldn't you just say Riley.name originally? Like,
Because the instance variables are protected. They're not accessible from outside. So these @name and @breed and @whatever are only usable inside of the class. Someone from the outside world cannot reach into the details of the dog class and pull out an instance variable unless I say attr reader. I'm telling Ruby, please allow other people to read my name instance variable. Please allow other people to read my breed instance variable. Right? Let's add another attribute up here called age. How old are these dogs? So let's store the age. And then when we create these dogs, Riley is 3 and Roscoe is 7, I think, or 8. We'll say 7. All right. Now it has 3 instance variables. And if I wanted to be able to say from outside, Riley is Riley.age years old, right? At first, I'm going to get an error because there's no age method defined on dog. I need to tell it, yes, also allow there to be an age method. Riley is 3 years old. What if now, question?
Sorry. So the colon name corresponds to the keys, the @name, it'll always correspond to that on the left.
Mhm.
And the arguments you pass into the initializer are always going to be the values on the right. They have to line up too.
So almost. The symbols here are which instance variables do you want me to expose? So if I have colon name, this means that my dog instances are going to have a .name available to them, and it will reveal the @name instance variable. Notice that the arguments to initialize, right, I were just storing in @name, @breed, and @age. These names here are Taco Tuesdays. I could call this A, B, and C. But the instance variables are going to have nice names because I want my dog to know it has a name and a breed and an age. I'm not going to Taco Tuesday these. I'm going to come up with good names. These names of these instance variables are the same as these symbols, which are the same as these method names down here. They all tie together. If I need to populate them when a dog is created, I will pass in variables that have those values and then store them in the instance variables.
So I
I'll
guess
get to you,
that's
Shane.
my question, the dog name has to, it has to say the dog name where it says name for the value. You can't say, so now you have to change each one of those to taco 1, taco 2, taco 3. Yes, okay. Yeah, I just want to make sure that.
Right? I'm using these arguments to pass information in, right? If I were doing this as a real program, if I was programming this for a job, this would be name, this would be breed, and this would be age. Name, breed, age. Because if I'm thinking of a name for some information, name, breed, and age is what I would call them. It's what I'm going to call them as arguments. It's what I'm going to call them as instance variables. For students on their first couple of days of Ruby, at name equals name and at breed equals breed. It gets a little confusing, which is why I tend to use longer names for my arguments than I do for my instance variables. Shay, you got a question?
Yeah, the below the class at the programmer's print. So you're. Okay, I'm just trying to understand it.
This one here?
Yes.
I'm just-
Never mind. Actually,
Yeah. I'm just printing what's inside of this object.
Yeah.
Hey Riley, what are you? Right? Are you a string? Are you a number? Oh wait, you're an instance of dog. You're an instance of this class. You are a dog. You live here in memory. Who cares? We never use that. Your instance name is Riley. Your instance breed is Dachshund, and your instance age is 3. As opposed to the Roscoe variable, which is also a dog, which lives here, whose instance name is Roscoe, whose instance breed is Dachshund, and whose instance age is 7.
Okay, I actually do have a question.
Mhm.
No, this is a new one. If you were to print Riley, are you able to drill into that somehow? Like.
Well, see, this is why we had to add the at name and the age,
Yeah.
right? That's why we had to add these. What happened? We lost age. Right, we had to add the age.
Oh, okay. So there's no way that should go straight from like the dog.u.
No,
Okay.
right? So what normally we do is we make a new instance of something, and then we're going to call methods on it or ask for attributes of it, which are our instance variables. Right, so now Riley is 3 years old. Riley is 3 years old.
Would it return nil if you didn't define Riley's age and tried to?
Well, if I made an add a reader for taco, right, and I tried to print Riley.taco, there is no taco instance variable, so I would get a nil. Right.
If you made an at taco.
And if up here I said at taco is yum, what do you think this is not going to print after Riley's 3 years old?
Yum. Because there's
Yum.
Oh,
Right? The attribute reader taco allows me to say Riley.taco, which will give me access to whatever's inside of this taco instance variable.
even though you didn't pass it in as an argument down there.
Mm-hmm. I can make any instance variable anything I want, anytime I want, even if it's not related to something that gets passed in. Right? That's kind of where we started. If you rewind this video, if you're listening to this later, if you rewind this video back about 8 minutes or so, we had at name equals Riley in the beginning, even before I started passing in these arguments. Right? Let's be able to change Riley's age. Right, let's imagine that it's her birthday, and we want to change her age. Let's get rid of this taco business, right? I would like to say, hey, Riley, your age is now 4. It's telling me there's no method. Let's look at this over here. Let's make this really big. Undefine the method age equals. Well, that's interesting. I didn't write age equals. I said Riley age is 4. In Ruby, when you have something like Riley.age and an equals, Ruby really sees it like this, that the name of the method is age equals, and there's a 4, that's an argument. That's how That's how Ruby sees Riley.age equals 4. Even if I wrote it like this, Riley.age space equals space 4, Ruby sees that as, oh, you're calling the age equals method on Riley and supplying it a 4. That means that if I define a method up here, it's going to be a weird named method, age equals, and its argument is new age, defining a method called age equals with one argument. I can change Riley's age to be the new age. Right? The age equals method will take in one argument, and whatever I give it, I will make that the new instance age of Riley. And now, if I print how old Riley is, Riley's age has changed. Whatever I pass in here becomes her new age. Right? We do this so often that we don't need this. I can say adder writer age. And that will give me an age equals function that works exactly the way that I want.
Could you have just left the equals out? Because it looked like that's
No.
what it was, no?
No. I could not leave the equals out here, and I could not have left the equals out when I defined the method. The method is actually called age equals. I'll show you that in a second.
Okay.
This is a shortcut for def age equals new age. That age is new age. Right? This is so common, having a reader and a writer. We call this an adder accessor. So we actually don't need the adder writer here. We don't need the age here. Adder accessor is a shortcut for adder reader age, adder writer age.
So is that if, I don't know if it's the right word, two arguments, the same
Yeah.
variable was in each?
Yeah, we're saying that adder accessor means I want to be able to read the age and I want to be able to write to the age. This is what most Rubyists do most of the time, right? Maybe we would change this to being able to have a adder writer for name and breed. Let's make it adder accessor. That means I can do Riley.name equals a new name for Riley. Now I cannot. With just adder reader, I can only read the name. I can do Riley.name. I can't do Riley.name space equals and change her name.
Like if you wanted to do weight, because that's something will fluctuate,
Mm-hmm.
and that you would put it there because it was in both right and read.
Right. So let's do weight, right? And then let's print Riley's weight. What do y'all think Riley's weight's going to come up to being?
No.
Mil. Very good. Now if I say Riley's weight is 12 pounds, and I print Riley's weight, what am I going to get the second time? 12. So I didn't define anything on the initializer, or I didn't make def weight equals. Just by saying adder accessor weight, I get a weight method and a weight equals method.
Could you put a comma after the first adder accessor?
I could.
Okay.
I could also do it like this. This would also now if I needed to have a dog that could never have a nil weight, I'd have to add a weight argument here, pass it in, initialize it, etc. But maybe there are things where that's not so important, right? So you can see that a dog class, if we just did it the shortest way, might be like adder, accessor, name, breed, age, and weight. And when we initialize one, we're going to take a name and a breed and an age and say at name is name, at breed is breed, at age is age, and that gives us a little tiny dog class, right? We can give dogs names and breeds and ages and weights, and we can access them and change them, right? Just with just a little bit of code here. That would be our shortest dog class, right? So if we have these classes, like a dog class, we can also make specialized versions of dogs, right? So dogs so far have names, weights, ages, and breeds. Let's make a new class called a good dog. And a good dog, right, is a kind of dog. In JavaScript, this was class good dog extends dog. Remember, class app extends React component, right? This is the idea of inheritance. The good dog is a child class of dog. Dog is the parent class of good dog, right? It's a parent and child relationship. Good dogs can do everything a dog can do. Right? So, anybody have a dog you want to share their name with? Spell it. And what kind of dog is he or she? And how old? We'll say 9. But we can also make this a good dog. And you'll notice that Callie is not a dog. Callie is a good dog. Right? It is a specific kind of dog, but it has all of the same attributes as a dog. Let's give good dog a method. Thanks. So now good dog has a method called treat. And if we say Callie treat, thanks. We can even use our instance variables. Right? Callie says, thanks, because she got a treat. But if I try to say, stop it, keyboard, Riley treat, I'm going to get an error. Because even though she is, Riley is not a good dog. She's just a plain old dog. So Riley does not have treat, because treat is only available on good dog classes that are inherited from dog. Right? This is a way of specializing classes. I want good dogs to have everything that a regular dog can have, and possibly more.
If you wanted to take it another level, could you do better dog extends good dog, and then it goes back to
Yep, it goes as deep as you want. But every class only ever has one parent class, but a class can have many child classes. So we could have a class bad dog that also derives from dog, and maybe the def treat method says, no, you're not a good dog. We can also change methods that are in the base class. So we have the speak class, right? Where the speak method puts I am a good dog, right? So when Riley, let's get rid of the Riley treat. And let's call Callie speak, right? So when Riley speaks, Riley says, the dog named Riley that is a dachshund says woof. But when Callie, a good dog, speaks, it calls a different method. we've overwritten the speak method on the base class, on the parent class. So the speak behavior is now different for good dogs than it is for regular dogs. And we're going to see the use of base classes when we get to working with Ruby and databases. We're going to see that the base class, just like React component, gives us a lot of power. Right? We're going to see some classes that our code can derive from where we get a lot of that behavior for free. Right? It's a pretty typical pattern of saying some library has a class that's really powerful. My thing is a customization of their powerful thing. My app component is a React component, so I get rendering and state and events and click handlers and all the things that React component gives us without me having to define it. Right? This seems like a small contrived example, but what you'll find this class and child class is maybe your team works with bank accounts, right? So maybe there's a core class bank account, right? And it has all this behavior, and then your job is to create a new kind of bank account, right? We're gonna have special customers, and there's a VIP account, right? And every time someone makes a deposit, right, they get points towards prizes, right? So that class VIP account would have a different deposit method that would be adding to some counter, and then asking the base class, yeah, do your deposit behavior. The VIP account has already done its counting, right? So you will find on teams that people will create core classes and then extend them when there needs to be customized behavior. We're going to start seeing this mostly from using other libraries' classes. We probably won't be making our own derived classes, but we need to see how they work. So when we use that language feature, we kind of know what's going on. So hopefully some of this looks a little familiar and some of it looks a little different. That pattern is going to keep happening as you learn languages, right? This syntax is a lot like JavaScript, except we have the def for making our functions, and we use the at instead of this dot. And then we learn the add or reader, add or writer, add or accessor for exposing those methods outside. But most everything else is kind of the same. We use initialize instead of constructor. I kind of wish they used constructor. It's a better word. It's easier to type because there's too many I's. INITIALIZE, and I end up typing it wrong most of the time. Right? We do dog.new instead of new dog. Whatever, the new is just in a different place, but the idea is the same. And calling methods is the same. Right? So the idea of classes here from JavaScript is the same. Again, JavaScript classes have been a later addition to the language. They've borrowed from Java, C#, Ruby, and other languages that had class-style definitions before JavaScript did. Right? But you see, right, languages tend to flex and borrow from each other. JavaScript is borrowing, so we can kind of have this mental model that works now across multiple languages. The syntax is just slightly different, and the behavior is just a little bit different.
Do you need an accessor to access something from inside a child class?
We do not.
Okay.
So the child classes can also see all of the instance variables,
Okay.
right? But the child classes can also use the accessors, right? So the child class can also use the accessors by just calling the name of the thing, right? The same thing is true inside of the class. Now that I have these accessors, I can just say name, and I can just say breed, and I can just say wolf, right? This is why the parentheses that are being optional are so nice. Doesn't this just look like I'm referring to the variable? What's really going on is Ruby is doing this. What Ruby is really doing is, remember this dot in JavaScript? Well, in Ruby, we call that self. So this is what it would look like if we did not have the syntax flexibility in Ruby, right? This is kind of what it looks like in JavaScript, right? With the backticks, this dot name parentheses. Well, in Ruby, the self or the this is always implied. If you don't say self dot, you're always talking about your own class, so we can get rid of that. And we said that the parentheses on function calls are optional, so we get this, right? This is where the syntax flexibility of Ruby really helps, right? It looks like we're accessing a variable, but it's really a method. Where did that method come from? It came from here by defining these accessors, right? When I say Ruby has syntax that tries to get out of your way, this is what I mean, right? And the reason why we would write it this way rather than @name, let me show you. So right now, this says the dog named Riley, because the dachshund says Wolf. What if we always wanted, when we were accessing the name, we want it capitalized? We could introduce the method again and have name return uppercase, right? So now, the dog named Riley, right? So if we didn't have this, if we said @name, we'd be reaching in and touching the instance variable, right? We'd be directly touching the variable that is capital R-I-A-L-Y. But if we're really referring to this as like an accessor, right? The thing that is name, if we drop the @ sign, if later on somebody comes on along and redefines how name works, and we mean, no, we always want the name capitalized for some reason, or in this case, uppercased, or maybe we want there always to be quotes around it, whatever it is. If we just say name and use the accessor, somebody can come along later and define a method, and all the rest of our code behaves the same. This pattern also repeats a lot in Ruby, right? So we would probably, on a team, not use the instance variables once we had the accessors. We would use the accessors inside of the class and outside. We would only use the accessors here, the instance variables, to initialize. And even still, if we made these attr accessors, right? Advanced topic here for a second. If we made these attr accessors, now we have a name equals method, right? We should be able to do this. But unfortunately, this is the one place where you have to say self dot. Now we are programming everything in this class without ever using the @ symbol. Some programmers will code like this. They will use self.name equals self.breed equals self.age equals in the initializer to convey that they're using the accessor. Some do and some don't. I don't mind if you keep to this because I think it's a little bit easier to understand. Yeah. It's kind of an optional fancy thing that the language gives us. But most of the time, I use the instance variables in the initializer, and then I set up accessors, and I never use the instance variable again. I just use it to say, hey, I'm initializing this variable, and I use the accessors everywhere else. When you see me write Ruby code, that tends to be how I write. If you also use the @name here, right, nothing wrong with it. This is just a little bit better. So this is the idea of classes. You'll see they're pretty much like JavaScript. When we come back to Ruby on Monday, we're going to be combining variables, arrays, hashes, and classes. Right? We'll do a review of that, and then we're going to tie them in with the database, and then we're going to tie that in with the web. And by the end of next week, we're going to be building full backend applications on the web. We're going to tie our class information, our database information we're going to spend the next 2 days on, and then on Monday of next week, we're going to learn how to make an API and then tie all that together. Right? Cool. So hopefully some of this feels a little familiar. The homework this afternoon is Ruby koans, which are going to be like the JavaScript koans that you all did. When we get back together, please go look at them. When we get back together at 3, I will show you how to navigate through them because I feel like the Ruby koans are a little bit harder to understand how to work your way through, but at least go through the setup instructions. So when we get back together at 3, I can walk you through the first couple of them and talk about some of the things I don't love about the Ruby koans, the way they're set up. Right? And that's what we'll do at 3. Cool.
For that second kata in Ruby,
Which one was it?
the remove all the exclamation points except for the ones at the end.
Yes. Mm-hmm. Yeah.
And
Cool.
maybe in JavaScript too, for your time.
Yeah. Yeah. For sure. Cool.